All right, today we're going to take a look at graphing sine and cosine functions. Today we're actually going to graph sine. Tomorrow in class we'll graph cosine. So we're going to do half the notes today, and then we'll do half the notes tomorrow. All right, so taking a look at a couple of the vocab words. All right, so domain. We know domain is the x values, okay? But domain represents the angles that we're going to plug in for x, right? So we always have sine of something, and that's 30 degrees, 40 degrees, or 45 degrees, etc. So the x value or the domain always represents the angle. All right, the y value is, or the range is the y values, or the 1/2, the root 3 over 2, or the values that you get when you plug in those angle measures to the trig function. All right, amplitude. Amplitude is going to be half the distance from the highest to lowest point of your graph. Okay, so we're looking at the y values. So we're going to find the middle, and we're going to go half the distance from the top to the bottom. All right, and then period. Period is how long it starts before the graph how long it takes before the graph starts to repeat. So we'll take a look at that as well with our graphs. All right, so some critical values. We're going to talk about these every time we graph. On the y-axis, you're going to graph the maximum and the minimum. We're also going to graph x-intercepts. When graphing one period of the trig function, you're going to need 5 points on your x-axis. So we'll talk about how to find those 5 points. And then our y-axis will need 3 points, a high, a low, and then the middle, or we'll call it the midline. All right, so let's start by looking at the sine function. Okay, so if I think of my xy axis, I know over here at 0, I have the point 1, 0. I know up here at pi over 2, I have the point 0, 1. Over here at pi, I have the point -1, 0. And then down at 3 pi over 2, I have the point 0, -1. So those are going to be our main values that we look at when we graph. Okay, because we know that when we go around the trig graph, or when we go around the unit circle, those values start to repeat. So we're going to look at how long it takes before those values repeat. So if we talk about the sine value, we know the sine value of 0 is the y value. So sine of 0 degrees, or 0 radians in this case, is 0. Sine of pi over 2 is the y value up at pi over 2, which is 1. Sine of pi is the y value over at pi, which is 0. So it starts to repeat there. But then if you go down to the y value at 3 pi over 2, we get -1. So it's actually not repeating yet. And then we go back to 0 for 2 pi. All right, now if I were to continue after 2 pi, up here, if I take 2 pi plus pi over 2, I'd get 1 again, and then 0, and -1, and 0. And as I keep going around the circle, I keep getting those values to repeat. So what we're looking at right here is what we call one period of sine. So the period of sine, it starts to repeat after we go 2 pi on the x-axis. So once we go from 0 to 2 pi, and then those values start to repeat. All right, so we said that on the x-axis, we always need 5 values. So we know our starting value is at 0. We know our ending value is at 2 pi. We know that pi would be right in the middle of 0 and 2 pi. We know that pi over 2 would be in the middle of the left 2 points. And then 3 pi over 2 is in the middle of the 2 points on the right. We're going to talk about how to find those a little bit more specific when those numbers change. All right, and then our y-axis needs 3 points. So I need a 0, I need to go up 1, and I need to go down 1. So when we graph the parent function, or just the generic sine function, I start at 0, 0. I go up to pi over 2, 1. I go back to pi, 0. I go down to 3 pi over 2, -1, and I come back to 2 pi, 0. So we go up, we come down, and we come back. Now, this graph does not stop. If I were to keep going and I were to go pi over 2 more, so that would be what? 5 pi over 2, right? Because this would be 4 pi over 2. Then I would go back up to 1. And this graph is going to continue to repeat as I keep going further around the unit circle more than once. In addition, if I were to go backwards and if I were to go to -pi, it would go down, right? If you think about it, if I go -pi, that would get me -1. And then it's going to come back up and it's going to repeat that same kind of wavy pattern that it has. But the one thing we need to remember is that sine starts at what we call the midline, or the middle of the graph on the horizontal, or up and down on the vertical axis. It starts in the middle, it goes up, middle, down, middle. So it hits that middle or that midline 3 times when we graph the graph of sine. All right, so we talked about the period of sine. Period of sine is always 2 pi. So the sine graph starts at 0, it goes up, down, middle, up, and then it would start to repeat. So from 0 to 2 pi is the distance it takes, or how long it takes to repeat. All right, amplitude is half the distance from the top to the bottom. So I know from 1 to 0 is 1 unit, and from 0 to -1 is another unit. So that's 2 units tall. And if I take half of that, it is just 1. So my amplitude is 1. I can also think about it from the midline up is 1, or from the midline down is 1, and that would also be my amplitude because that's half the distance up and down. All right, domain. So we don't have any undefines when we graph sine, actually, or cosine. So the domain of sine is going to be from -infinity to infinity, because we can just keep this graph going on forever. And as well, we could go to the left. And then our range, if you look at our lowest point is -1. So it's a bracket at -1 because there are actual points at -1, all the way up to +1 with a bracket. Okay, so again, looking at that graph of sine, it just starts at 0, 0, goes up to 1, back to 0, down to -1, and back to 0 at 2 pi with a period length of 2 pi. All right, so let's talk about what do these values do. All right, so it really doesn't matter. We've done this with functions. Now we're talking about if there's a sine or a cosine as a function instead of absolute values, square root, log, exponential. So all the A, B, C, and D always do the same thing no matter what function it is. So let's start with A. So we know A is our vertical stretch. It could also be our vertical shrink. So if A is bigger than 1, we know it's a vertical stretch. Okay, if A is between 0 and 1, so if it's a fraction between 0 and 1, it's going to be a vertical shrink. So we're going to make that graph shorter. And then we also know if A is negative, okay, it reflects over the x-axis. Okay, so if I were looking at my sine graph and I wanted that to flip over the x-axis, instead of going up first, it would go down first. And then instead of going down second, it would go up. So it would just go down, up, and back to the middle. Okay, so that's what it would look like if it flipped over the x-axis. Okay, so those are my A values. Those are my vertical movements. All right, I'm going to leave some room here for B and leave some room for C. I'm going to go to D because remember, anything on the outside is my Y values. So those are my other vertical movements. And we know that plus D shifts up D units and minus D shifts the graph down. So that's my vertical shift. All right, anything that touches X does the opposite. So we know that the C value moves it left and right. But remember, if it's plus C, it actually goes left C. You would think the positive would move it to the right, but it actually does the opposite. And then minus C actually moves it to the right C. You would think negative would move it back, but it shifts it to the right C units. All right, and then for the B value, we know that B is our horizontal stretch and shrink, and then also a reflection. So if B is bigger than 1, we know that it's a horizontal shrink. Okay, and remember, it's a horizontal shrink by the reciprocal. So if it was a 2, it's a shrink of a half. If it's a 4, it's a shrink of a fourth, and so on. If B is between 0 and 1, so if it's a fraction like a half, a third, it's going to do the opposite. You would think it would shrink, but this is going to be a horizontal stretch. Okay, and it's a horizontal stretch by the reciprocal. So if it's 1/2, it's going to stretch by 2. If it's 1/3, it's going to stretch by 3, and so on. All right, and then last but not least, if B is negative, that is a reflection over the y-axis. So it would flip over the y-axis. And we're actually not going to work with this one with the trig functions. We did with parabolas, we did with snakes, we did with square roots. But with the trig functions, we're not going to mess with a negative B value. All right, so we're going to actually do this a little bit different. Now, you can still do it with the tables where you make your parent graph and then you multiply your x's by certain numbers and add, and then multiply your y's by certain numbers as well. We're going to do this a little bit different, okay? So we're going to first find the 5 points on our x-axis, right? So remember, the x-axis needs 5 points, and our y-axis always needs 3 points. So every time we graph sine, cosine, tangent, when we graph all the trig functions, we're going to need 5 points on our x-axis. All right, so the first thing we're going to do is we're going to find what I call our starting point. Okay, normally our graph starts at 0, or the first period that we're going to graph starts at 0. Okay, but if we shift left or right, that starting point's going to change. So you find your starting point using the c value. Okay, if it shifts right, pi over 2, we start at pi over 2. If it shifts left, pi over 2, we start at negative pi over 2. All right, the second thing we're going to do is we are going to find the period. Okay, so to find the period of sine, what we're going to do is we're going to take the normal period of 2 pi, and we are going to divide by the b value. So the normal period's 2 pi. If b was a half, it would stretch it, so it would make it 4 pi, right? It would double the period. If our period was, or if the b value was 4, we would do 2 pi divided by 4, and it's going to shrink that period and make it pi over 2. So to find the period, we are going to do 2 pi divided by b. Always, if b is a fraction, you're going to multiply by the reciprocal, and it's going to make that number larger. All right, the third step is what we're going to do is we're going to find our endpoint. Okay, so we're going to find our endpoint. And to find that, we're going to take the c value, or we're going to take, I should say, our starting point. And then we're going to add the period. And that's going to get us to the end. Okay, so starting point, and then we figure out what the period is. We add the period, and that's where we're going to be our end. All right, and then the last thing we do is we find our midpoints. Okay, so we're going to find 3 midpoints. Because remember, we need 5 points. We got a starting point, we've got an ending point, and then we got to find 3 points in the middle. Okay, and the way we find our midpoints is we add the 2 endpoints and divide by 2. So we're going to do an example or a couple examples in a minute. And those are going to be the ways that we find our midpoints. We take our 2 points on the end, we add them up, cut it in half, and that finds the middle. All right, the y-axis is much easier. Okay, the first thing you're going to do is we are going to find what we call the midline. Okay, and the midline is going to be our d value. So normally the middle of the graph is at 0. If the graph shifts up 2, our midline is going to be at 2. If the graph shifts down 5, our midline is going to be at negative 5. Okay, and then what we're going to do to find the other 2 points is we are going to add and subtract, whoops, that would need a U, subtract the amplitude from the midline. And that's going to get us a top point and a bottom point. Okay, so I know that seems kind of weird for right now, but we're going to do this actually for almost all of our graphs, whether it's sine, cosine, secant, cosecant, cotangent. The only one that we're not going to do this for is tangent. We'll talk more about that as we get there. But we're going to follow these x-axis steps and then the y-axis steps every single time. All right, so the first thing we're going to do is we are going to graph y equals negative sine of 2 times x plus pi. Now, the one thing I want you to notice that there's no d value, right? That d value is 0, okay? And then we have a 1 in front here, so there's not a vertical stretch either. There's just that reflection over the x-axis. All right, so the first thing we want to do is we want to find our starting point. So I know this graph, or this plus pi, actually shifts my graph left pi. So I'm going to go ahead and put negative pi as my starting point. All right, the next thing I want to do is I want to find the period. So I've got a space over here for period. So the period is always 2 pi divided by b. Well, in this case, our b value is 2. So we're going to do 2 pi divided by 2. So our period is just pi. All right, so far we did step 1. We found the starting point. 2, we found the period. Those weren't too bad. So now we got to find where this graph would end. So if we start over here at negative pi, what I'm going to do always is I'm going to find my end point, and I'm going to find that by adding the period. Okay, so I'm going to add the period, and this period for this graph is just pi. So I'm going to add pi. Well, if I take negative pi and pi, that puts my n at 0. Right? So my entire sine graph is going to happen in between negative pi and then 0. All right, so now I've got to find my midpoint. Okay, so the point in the middle, the way we find that is we take the two endpoints, as it says up here, we add our two endpoints and divide by 2. So if I take negative pi plus 0, that's negative pi. If I cut it in half, that's negative pi over 2. All right, so that's only 3 points, and we said that we need 5 points, so that means I need a midpoint on the left, and I need a midpoint on the right. So I'm going to find the one on the right first. If I take 0 and negative pi over 2, that's negative pi over 2. And if I take negative pi over 2 and I cut it in half, that gives me negative pi over 4. So the right midpoint is going to be negative pi over 4. All right, this left one's going to be a little bit harder, but if you think about pi in terms of halves, negative pi would be negative 2 over 2, right? Negative 2 over 2 is the same as negative 1. So having that common denominator is going to make it much easier. So if I take negative 2 pi over 2 plus negative 1 pi over 2, that gives me negative 3 pi over 2. And if I cut that in half, multiply it by a half, that gives me negative 3 pi over 4. So my last midpoint is negative 3 pi over 4. So I'm going to get rid of that common denominator there. And now I've got my 5 points. I don't know why I did that one in green, so I'm going to switch that. So my endpoint is at 0. All right, so now we've got our x values. We've got to find our y values. All right, so to find our y values, the first thing we need to do is find our midline. And our midline has to do everything with that vertical shift. Well, right now there's no vertical shift. So my midline on the y-axis is going to be 0. All right, my amplitude, that's my vertical stretch. Okay, so the amplitude always has to be positive, and it's going to be the number in front here. And in this case, there is a 1 there, so my amplitude is 1, right? There is no vertical stretch here. If there was a 2 in front, my amplitude would be 2. If there was a 1/2 in front, my amplitude would be a 1/2. It's the vertical stretch or shrink. All right, so what I need to do is I need to go up 1 and down 1 because I'm going my up and down my amplitude from the midline. So up 1 and down 1, and that gives me my high and my low point. So now I've got my 5 points on my x-axis. I've got my 3 points on my y-axis. Now I got to think about my graph. So I know the normal graph of sine starts at the midline. It goes up to the top, back to the midline, down to the bottom, and back to the midline. Okay, but the only downside here is we've got a negative sign in front. So now our graph isn't going to look like that. It's going to start at the midline. It's going to go down, go back to the midline, up, and back to the midline. So my graph now is going to look like the black graph I just drew. All right, so we have to start. We're not starting at 0. We have to start at the midline. We're going to be at the midline at the start, in the middle, and at the end. So I can go ahead and put my points at the start, at the middle, and at the end, and it's my midline, which was at 0. Okay, now, instead of that graph going up first like it normally does, it's going to go down first. And our next point is where it goes down, and it goes down my amplitude, right? So my y values, the top and bottom y values, where it's going to hit. So it goes down, comes back to the middle. Now this point over here is going to go up, right? Because it normally goes on down on that side, but it's flipping, so it goes up. So my negative sine graph looks like that. Okay, again, it looks like the sine graph, but flipped. So then we've got to do domain. So our domain is always from negative infinity to infinity. We don't have any asymptotes. We don't have any holes. This graph just keeps going. Remember, it doesn't stop there. It would then go down and up and down and up. And on the other side, it would go up and down and up and down. And it would continue that pattern. We're just graphing one period. All right, if I look at my range, my lowest value is -1. My highest value is +1. And that's because there was no stretch. If it would have stretched by 2, it would have been from -2 to +2 because that midline is at 0. So I always recommend doing the domain and range at the end, just because then you have your picture of your graph. But the period and amplitude you have to finish, or you have to figure out prior to graphing. All right, we're going to skip example 2 because we're going to do cosine tomorrow. But again, it's very similar to what we're doing. We're going to skip example 3 and we're going to jump right to example 4. All right, example 4 has a bunch of numbers there. We've got a 1/2 in front. We've got a pi as our b value this time. We've got a -1, and then a plus as our c value, and a +3 as our d value. So it doesn't matter if you do the x or the y values first. I'm going to go ahead and do the x values first. And we have a shift to the right of 1. So I know my graph is going to start somewhere here at about 1. All right, if I look at the period, remember the period is always 2 pi divided by the b value. In this case, my b value is pi. So this one actually works out pretty nice. I get 2 pi divided by pi, which is, which is not pi, which is just 2. I swear I can divide. All right, so remember to find our endpoint, we're going to add the period, which in this case, we're going to add 2. So notice when the b value has a pi in it, our pi's cancel out. So this is going to stop at +3. All right, so now I've got to find my middle point, right? My midpoint here. And to do that, we add the outside. So 1 + 3 is 4. 4 cut in half is 2. Okay, it doesn't matter which one you find first. You got to find both. I'm going to do the right one first. 2 + 3 is 5. 5 cut in half. I'm just going to go ahead and leave it as 5 halves. I don't necessarily want any decimals. Anytime we have the pi's, we definitely don't want decimals. I want things like 5 pi over 2 if this one had pi's in it. All right, and then on the left side, 1 + 2 is 3. 3 cut in half is just going to be 3 halves, which, yes, would be the same as 1.5, but we're going to leave everything as fractions. All right, so I'm good here. I have my 5 points on my x-axis. All right, so now we got to do our y-axis. So remember, our midline is always this guy right here. So we're going to go and we're going to start up 3. Okay, so that's going to be the middle of my graph. And then my amplitude is the a value. Remember, it's always positive. So in this case, it's going to be a vertical shrink because it's a half. So what we're going to do is we're just going to go up a half to, we can either call it 3.5 or 3 1/2. And then we're going to go down to 2.5. Now notice I didn't have some great spacing here, but that's okay. As long as you have these 3 points labeled on your x-axis or on your y-axis, you're good to go. All right, so now when we think about the sine graph, normally our sine graph goes from the middle, up, middle, down, middle. And that's going to be the way that our graph looks here because it doesn't have a negative sign in the front. Okay, so remember, it starts at the midline. Okay, so at 3, and then at our first x value, which our first x value is that horizontal shift at +1. So we're going to go right here, and this is going to be my midline. Now we know we're going to hit our midline again at 2, and we're going to hit our midline again at 3. Okay, and our graph goes up first, so it's going to go up. So at 3 over 2, we're at 3.5. And then it's going to come back to the middle, and then it's going to go down. So at 5 over 2, we're at 2.5. All right, so all I have to do is trace that graph right here. So it goes up, it goes down, and it goes back there. Now, notice I'm not putting any arrows at the end because it doesn't go up forever and it doesn't go down forever. This graph is going to keep just bouncing in between 2.5 and 3.5. So we are good to go there. We started a point, we ended a point, and we've got our period in between. All right, domain-wise, again, our domain's always going to be -infinity to infinity. Now we have to look at our y values of our graph. So our lowest point is 2.5, our highest point is 3.5. So my range is from 2.5 to 3.5. All right, now I will say sometimes the x-axis, it has some fractions in there, so that's nothing to be scared about. Okay, same thing up here. We had to do some fraction work off to the side, and that's something that will have to be done, especially if you don't have common denominators. All right, so your homework is to graph or to do worksheet 5.8, day 1, and then we will graph sine tomorrow. Thanks.